Good morning, all of you. We will continue the previous class problem. Find the exponential Fourier series for the given continuous time periodic signal. Okay. The fundamental time period of the signal is 2 and omega equal to 2 pi by t, pi radian per second. So in the next step, we have to write the expression for this signal x of t. Between -1 to 0, it's increasing slope. And from 0 to 1, it is a decreasing slope. So find out the expression for x of t. Okay. So what is the formula I suggested for you previous classes to find the equations, particularly between t between -1 to 0, t between -1 to 0. So general formula y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. Okay. So use this basic formula. Here y represent your x of t. In y-axis, what is the variable x of t? So x of t minus y1. So this particular point x1 y1, that is -1 comma 0 divided by y2 minus y1. So what is y2? Y2 value 1 minus 0 equal to x. In x-axis variable here t minus x1 minus of minus plus 1 divided by x2 minus x1. Okay, x2 minus x1. So what is the x2 value here? 0. 0 minus of minus 1. You get plus 1. Okay. Now it is clear your x of t expression is t plus 1. So from this equation, you write down the expression for x of t. X of t by 1 equal to t plus 1 by 1. That is x of t equal to t plus 1. Between for -1 to 0. Okay. Now 0 to 1. 0 to 1, this is the slope. So now this point considers x1, y1. This point considers x2, y2. Okay. x1, y1, 0, comma 1. At this point, x2, y2, 1, comma 0, magnitude 0. Now use the formula for 0 to 1. Repeat the same procedure once again. Y minus y1. Y-axis here variable is x of t. X of t minus y1, 1. Y2 minus y1. 0, y2, 0, y1, 1. 0 minus 1, 1. Minus 1. X, that is t, variable t. X minus x1. X1, 0. X2 minus x1. 1 minus 0, 1. Correct? Y minus y1 divided by y2 minus y1. Okay. Now from this equation, solve for x of t. Solve for x of t. So x of t minus 1 or minus of x of t plus 1 equal to t. Okay. So I need the expression for x of t. T minus 1 or x of t equal to 1 minus t. X of t equal to 1 minus t. So x of t equal to 1 minus t for t between 0 to 1. Okay. So we have solved 3 different type of problems. One is standard sinusoidal signal or standard cosine waveform. Then you have to use a cos omega naught t. or A sine omega naught t. And second type of signal, some constant value, some DC value will be there. So you can write your mathematical expression for the given signal easily. And third type, this kind of slope is given for each and every time interval. Look at the shape of the signal. Here it is increasing slope. So between these 2 points, use this mathematical equation for straight line. Okay. And this is another slope. So consider this particular slope as the different categories between 0 to 1. Okay. Now the expression for this particular signal x of t, it lost. Therefore, the mathematical expression for the given signal t plus 1 between -1 to 0, 1 minus t between 0 to 1. Okay. So now we can calculate easily the exponential Fourier series coefficient AK. So remember the formula for integration UV. So what is the exponential Fourier series representation of a continuous time periodic signal? Any signal, any periodic signal can be represented by x of t equal to summation ak e power jk omega naught t, where where k varies from minus infinite to infinite. So what is the AK? AK is the exponential Fourier series coefficient. Formula 1 by t integration over the time interval x of t e power minus jk omega naught t into dt. Okay. So for this given problem, we have to solve in two steps. For AK, AK equal to 1 by t. 1 by fundamental time period is 2. Next, -1 to 0. X of t is t plus 1. T plus 1 e power minus jk omega naught. Here omega naught value pi into dt. Plus integration 0 to 1 x of t value 1 minus t e power minus jk pi t dot dt. Okay. So solve this integration and finally simplify for AK. So to solve this, let me take this particular point as one term. This is another term. So solve it separately and then combine together. It's better, right? So part A, the solution for part A, integration -1 to 0 t dot e power minus jk omega naught t into dt plus the integration -1 to 0 e power minus jk pi t dot dt. Okay. Or 1 plus t. Okay. So now UV formula. This is U, this is V. So integration of UV dx. So U integration V, last class. Okay. U integration V dx minus integration of U dash and integration dV dx. So this is U integration V. Substitute your limit minus integration of U dash integration V. So here T is U and this term is V. So T into e power minus jk omega naught t divided by minus jk omega naught. So omega naught already we replaced by pi. e power jk pi t. So minus jk pi. Okay. So u integration b. Substitute the limit minus 1 to 0. And minus of integration minus 1 to 0 u dash differentiation with respect to t dt 1 integration e power minus
Sir,
jk pi. Yes, hello.
సార్ అక్కడ సెకండ్ టర్మ్ ఇంటిగ్రేషన్ 0 to 1 కదా సార్, -1 to 0 అలాగేంటి సార్?
No, no, I'm solving this step separately.
ఓకే
1
సార్.
plus t e power minus jk separate
అర్థమైంది
because
సార్.
it will be very lengthy. Okay. So we'll solve one by one. So term A only I'm solving now. Okay. So minus integration of u dash v dash again now dt. This minus and this minus will get plus. So first term 0. If we substitute 0 here, 0 dot this value will become 0. Okay. So according to the formula, minus of this minus plus, but t replacing minus 1. So minus 1 e power t minus 1 e power jk pi divided by jk pi. Correct. T 0. If we substitute t equal to 0, e power 0 1, but 0 dot anything 0. So as per the formula, minus of, then you have to substitute lower limit, minus this minus will be plus. Anyway, t replaced by minus 1. So minus 1 e power minus 1. So e power jk pi by first term. Second term e power minus jk pi t divided by minus jk pi once again. Now substitute minus 1 to 0. Okay. So solve this. First term minus e power jk pi divided by jk pi. J square value minus 1. Minus already here one minus is there. So in the denominator term, you will get k square pi square. Okay. Denominator term k square pi square. Now substitute your upper limit e power 0 1 1 minus of t replaced by minus 1. So e power jk pi. It's the second term. 1 minus e power jk pi. So minus e power jk pi divided by k pi. Okay. Right. U integration v and plus integration u dash.
Sir,
v.
another equation వస్తుంది అనుకుంటా కదా సార్?
That's I'm confusing it that. This part we are not at all solved. Okay. So this is UV format. So for that we got this result. Okay. Then this part is available. So e power minus jk pi t divided by minus jk pi. Here one more term, minus 1 to 0. Okay. Now solve it. Plus e power 0, 1 minus 1 divided by minus jk pi. So minus of this minus, I'll put plus. Then e power plus jk pi divided by jk pi. Correct? T value 0, 1 divided by minus jk pi. Minus of this minus will get plus. Now t replaced by minus 1. So minus into minus plus jk pi. So this is the answer for the first term. Plus 1 divided by minus jk pi plus e power jk pi divided by jk pi. E. Okay. Similarly, we have to solve for b. What is b term? 1 minus t. 1 minus t e power minus jk pi t. Part b. Integration 0 to 1. 1 minus t into e power minus jk pi t dot dt. So split this 0 to 1. E power minus jk pi t dot dt first. Then minus integration of 0 to 1 t dot e power minus jk pi t dot dt. Okay. Now solve this. Finally add a and b and we will check for the final result. Right. So e power minus jk pi t divided by minus jk pi. Integration limit 0 to 1. Okay. Minus. I'm putting minus common. Now UV formula. U integration b. E power minus jk pi t divided by minus jk pi. Limit 0 to 1. Minus integration of u dash v first. U dash 1 integration b. E power minus jk pi t divided by minus jk pi into dt. Okay. Then first term already done. Second term UV format. Now substitute the limit. E power minus j pi t. Sorry, jk pi. T replaced by 1. E power minus jk pi divided by minus jk pi. Then minus into minus, this would become plus jk pi e power 0 1. E power 0 1. Right. And minus of this term. Okay. T. T replaced by 1. So e power minus jk pi. And this term minus jk pi. A minus of anyway t is replaced by 0 0 dot anything 0. So this is the result for the first term. And now integrate this particular part e power minus jk pi t. Again shall we make this plus minus minus plus? Okay. Now e power minus jk pi t, I'll make it as plus. Jk pi minus jk pi. 0 to 1. Correct? Now combine e power minus jk pi divided by minus jk pi. plus 1 divided by jk pi. And I'll put minus into minus plus. So e power minus jk pi divided by jk pi. This minus into plus, I'll put minus. Sorry, I'm taking this part now itself. Okay, no problem. It's minus, okay, right. So denominator j square minus 1, already one minus is there, minus minus plus. So it will get k square pi square. Numerator e power jk pi, e power minus jk pi. If it replace t by 1, then minus e power 0 1. Okay. So this is answer for B. Now combine the answer for A and B. So the Fourier series coefficient AK equal to 1 by 2, that is available in the previous step. In the AK 1 by 2. Now we completed the answer for A and B. What is A? Minus C power jk pi. So add AB directly if possible. E power minus jk pi. All right. This term answer and this term answer. Okay. Can you check? E power minus jk pi divided by minus jk pi. Where is the answer? It's very lengthy. Okay, shall we write first? First, we'll write the b term. E power minus jk pi divided by minus jk pi plus 1 divided by jk pi plus e power minus jk pi divided by jk pi minus of 1 divided by k square pi square e power minus jk pi minus 1. So this is value for B. So A value 1 divided by minus jk pi first. 1 divided by minus jk pi. 1 divided by minus jk pi. Right? Plus e power jk pi divided by jk pi. Plus e power jk pi divided by jk pi. So last two term I have written first. Right. Next. Minus e power jk pi divided by jk pi. Minus e power jk pi divided by jk pi. Minus e power jk pi divided by jk pi. Is it minus? Okay. Minus e power jk pi. And last one, 1 by k square pi square into 1 minus e power jk pi. 1 divided by k square pi square into 1 minus e power jk pi. Is it correct? Combined everything. 1 by k square pi square 1 minus e power jk. Okay. Now check. I think except the last term, everyone should be cancelled actually, except this particular term. So let's check. So 1 by jk pi, 1 by jk pi. Correct. Here itself it is cancelled. Huh? E power jk pi minus e power jk pi, right? E power minus jk pi, e power jk plus. Okay, there itself it is cancelled. So the final result for ak 1 by 2. Now simplify this. If you take 1 divided by k square pi square common, 1 divided by k square pi square is the common. So 1 minus e power jk pi, first term. But here minus e power minus jk pi, minus into minus plus 1. Okay. Now further simplify this. So value for ak 1 by 2, 1 divided by k square pi square. So 1 plus 1, 2. 2, I'm taking minus outside. So e power jk pi plus e power minus jk pi. Okay. What is the formula? E power j theta plus e power minus j theta equal to 2 cos theta. Okay. So e power jk pi plus e power minus jk pi replaced by 2 cos k pi. So the value for ak 1 divided by 2, 1 divided by k square pi square 2 minus 2 cos theta k pi. Okay. Now k is available in all the term. We take 2 outside. We take 2 outside. This 2 by 2 will be cancelled. So 1 divided by k square pi square 1 minus cos k pi. Okay. So what is the formula for cos n pi? Minus 1 power n. So the exponential Fourier series coefficient ak for this given continuous time periodic signal 1 divided by k square pi square 1 minus 1 power n. So this is the value for ak. Okay. If n is odd value, then ak equals 0. So ak equal to 0 for n odd. Okay. For n is even signal, 1 minus of minus 1 power n. Get 2, correct? Sorry, 0 for even.
సార్ అక్కడ ఈవెన్ కి 0 కదా
Yeah,
సార్?
yeah, correct. 0 for it. For n is even, 1 minus 1, 0. Right. For n is odd, then you will get 2 divided by a square pi square. Right. So read the problem carefully. If they are asking to derive exponential Fourier series coefficient, then up to this particular step is fine. AK fine. Okay. So in this problem, they are asking to draw magnitude response and phase response of the signals. So whenever if they are asking magnitude and phase response, in this case, we are taking n odd value. This is the result. N even value. This is the result. To draw the magnitude and phase response at k equal to 0, also we need to check. So a naught value you have to calculate. What is a naught? in 1 by t integration over the time x of t e power minus j k value 0. Okay, in the formula substitute k equal to 0. This is similar to your 1 by t integration over the t x of t into dt. Okay, so please remember that in exponential Fourier series, whenever you are trying to plot the magnitude response and phase response, you find a naught value separately. In ak formula, substitute k equal to 0. So a naught equal to 1 by 2 from minus 1 to 0, from minus 1 to 0, 1 plus t dot dt plus 0 to 1, 1 minus t into dt. Okay. So if you solve this, you will get a naught equal to 1 by 2. This step is, even if you are not drawing magnitude spectrum and phase spectrum, it is better to always find k equal to 0 value in exponential Fourier series. Okay. So for this given signal, we calculated AK general formula as well as at k equal to 0, what is the value of A naught? Right. Now in the questions, we need to draw the magnitude response and phase response. Magnitude response or magnitude spectrum. Okay. So your answer for AK, exponential Fourier series coefficient, actually it should be in the form of A plus JB. But what is the answer for this particular problem? Our AK value equal to 2 divided by k square pi square for n odd. Okay. And 0 for n even. As well as we calculated A naught value, that is also 1 by 2. So in this example, AK, the imaginary part is 0. This particular part is 0 for this particular problem. Okay. So do you remember, for a complex number a plus jb, to find the magnitude, that is modulus equal to root of a square plus b square. To find the angle of a plus jb, the formula is tan inverse of b by a. So in this example, this imaginary part is 0. 2 divided by k square pi square plus j 0. Imaginary part is 0. So tan inverse of 0 by anything, 0. Okay. So tan inverse of 0, 0 degree only. So first, let me complete magnitude response. What is magnitude response? K versus AK, right? K versus modulus AK. K equal to 0. That is the reason I computed A naught separately. K equal to 0, that is A naught. A naught equal to 1 plus 2 plus J0. Actually, imaginary part is not there. So modulus of A naught, root of 1 by 2 square, you will get 1 by 2 only. Okay. At k equal to 2, the magnitude is 1 by 2. You have to draw the magnitude response in the discrete way only. Signal is continuous time signal, but magnitude response, phase response, we have to draw in discrete only. We have to substitute k 0, 1, 2, 3, and so on. So k value 1. So k value 1 meaning k1. So 2 divided by pi square. 2 divided by pi square, that is less than your 1 by 2 only. This is 2 divided by pi square. Next, k equal to 2. For even value of n, ak 0. K equal to 3. 2 divided by 3 square pi square. That is 2 divided by 9 pi square. Okay. And 4, 0, and so on. At least minimum 4 samples you have to show it. Okay. This is modulus value, root of a square plus b square. So even if you substitute k equal to minus 1 also, you will get 2 divided by pi square. Minus 1. Minus 2, 0. For minus 3, you will get 2 divided by 9 pi square. Minus 4, 0, and so on. Okay, so this diagram called as magnitude spectrum. How the magnitude of AK distributed for various values of K. That is the meaning of magnitude response or magnitude spectrum. Do you understand? So for this example, our AK value 2 divided by K square pi square plus J0 for K value even. For K value odd, AK value 0. And separately we found the value for K equal to 0. Right. Now phase response, angle of AK, K versus angle of AK. So imaginary part is 0 for AK, even for A naught also. So for all the values of K, tan inverse of 0 by something. So tan inverse of 0, 0 degree. So for K 0 also 0 degree, 1 also 0, 2 also 0, 3 also 0, 4 also 0. Similarly, minus 1, minus 2, minus 3, minus 2. For this particular signal, this is a phase spectrum. Okay. For some other signal, if the answer is AK in the form of complex number, then for each and every values of K, we have to calculate the angle. Okay. So in generally, the magnitude will be symmetric. The magnitude will be symmetric. That is K equal to 1, what is the magnitude? Same thing available here. K equal to 3, what is the magnitude? Same thing will be available, K equal to minus 3. But phase angle will be reverse. So we'll see some other example. If for a K equal to 1, if positive pi by 2 meaning K equal to minus 1, you will get minus pi by 2 result. Okay, that is asymmetric. Sorry, clear about this? Little bit a mathematical formula we have to apply clearly. Signal sense system by Ramesh Babu reference book, and from the textbook some standard problems. Okay, if you practice these problems, we can attend the questions easily. No need to worry. So first problem like this, some DC signal, constant DC value, x of t easily we can write. Second problem in exponential Fourier series, some kind of positive slope and some kind of negative slope. Find the expression for x of t and substitute. Do the integration very carefully. It's always advisable to calculate A naught separately by substituting k equal to 0 in exponential Fourier series, so that we can draw the spectrum clearly. Right. So one more problem, just I'll start today. In the next class, we'll try to complete that. Several problems are there. I'm just solving the one model problem, so that you will get a confident. Whatever may be the signal given, the students can able to compute the trigonometric Fourier series as well as exponential Fourier series. T versus x of t. So what is the signal given to you? Minus tau by 2 to tau by 2. Okay. Magnitude is 1. Then some gap, 0. Here nothing is mentioned. Dotted line, it is mentioned as capital T. This problem from a Panium textbook. Okay. That's it. The signal sketch given to the student is only this much. So what is the fundamental time period for this problem? Find exponential Fourier series coefficient. Find exponential Fourier series coefficient. So what is the fundamental time period? Either you may consider minus tau by 2 to tau by 2, and then a constant is okay, correct? Up to this particular point. Time plus after. So this will give one fundamental period. Similarly, this on time, this complete off time. Okay, but we don't know what is this end point, or we may consider this particular point. This is also one fundamental time period, correct? Half zero from starting from zero. We may consider starting from zero up to t. Okay, from this particular point up to t. So what is the total time period? T. Okay, if this is t, meaning obviously this particular time period must be also t. It is a periodic signal. Okay, so how to solve this problem? So from this understanding, so we come to the conclusion the fundamental time period of a signal is t. Capital T is t only. So omega naught value 2 pi by t. So consider fundamental T is capital T only, omega naught 2 pi by t only. So with this assumption, we have to proceed the problems. Ak equal to 1 by t integration x of t e power minus jk omega naught. Okay. So we'll solve this problem in the next class.